Hey, welcome back to Math with Patrick and Quill. Today is July 27th, and we are solving problem number 208 from the Daily Epsilon calendar. And we need to find the number of non-prime factors of 1,200. And I think for this one, it might actually be helpful to find the prime factors of 1,200 first, because usually when you find the prime factorization of a number, you can then construct other factors, and then we can just take out those prime factors, because of course we need to count all of the non-prime or all of the composite factors of our number. So first off, when I'm trying to factor a number, I'm thinking like what times what brings me to this number. And the first split that I can see that seems pretty easy to tell is 12 times 100. Gets me back to 1200. And then I can keep splitting these numbers until I land on prime numbers. So 12 is the same thing as 4 times 3. And then since I can't break down this 3 any further with multiplication, like I could do 1 times 3, but then I'm just kind of repeating myself. Since this 3 is kind of the end of the line here, I'm going to put a box around it. And this will just denote that I found a prime factor of 1200. 4 is 2 times 2, and 2 is another prime number, and so I'm going to box those. 100 is the same thing as 25 times 4. And then, oops, I shouldn't box the 25 because I could still split that into 5 times 5. Those are both prime numbers, and then I have another 4 over here. So I have another 2 times 2. So overall, I know that I can construct the number 1,200 by multiplying 4 2s, 1 3, and then 2 5s. Cool. So yeah, I'm just kind of noticing 1, 2, 3, 4, and I'm just writing this prime factorization in this kind of exponential notation. All right. So I found the prime factors of 1,200. There's 2, 3, and 5. And using these prime factors, I can construct other composite factors of my number. Like, for example, I could grab maybe 2 2s. Let's say I don't grab the 3 right now, and then I grab the 5. And so I can do 2 times 2 times 5, which is 20. And 20 is another totally valid factor for 1,200. And essentially, I could pick any number of 2s. I could even pick none of them. So I could pick 0 2s, 1, 2, 3, or 4 2s when I'm kind of constructing one of these composite factors. I could either pick no 3s or 1 3, and then finally I could pick 0, 1, or 2 5s. So like each of these kind of numbers here, when I like kind of pick a number of 2s, pick a number of 3s, and pick an amount of 5s, this tells me that I have found another unique factor of 1,200. In this case, this would represent 8 to me because I'm doing 2 times 2 times 2, and then no 3s and no 5s. And so this number 8 is yet another factor of 1,200. And now I notice that I have 5 options for how many 2s I'm picking. I have 2 options for the amount of 3s, and I have 3 options for the amount of 5s. And whenever you're kind of in this scenario where you are trying to figure out how many options you have total between a certain amount of choices, you can just multiply those numbers together. So I have 5 times 2 times 3 total factors of 1,200. This number right here is 30. And then since it does say non-prime factors, I am just going to take out the 3 primes that I found earlier because I have 2, 3, and 5 as my prime factors. So overall, we have 27 composite factors or non-prime factors of 1,200. And I don't want to bother counting all 27 of them because it's kind of a lot. But 8 is one of them, 20 is another one of them. I could grab, a 2, a 3, and both 5s, and that would be, I think that's 150. 2 times 3 times 5 times 5. All right, this is 25, that's 6. Those together make 150. So I don't need to list out all 27, but You could create all 27 on your own if you really wanted to, by kind of figuring out how to construct them on your own by grabbing some amount of 2s, 3s, and 5s. Alrighty, I think that does it for me today. Thanks for coming along as always, and I'll see you in tomorrow's video. Bye.